Okay, so hello everybody. I'm Hector Gray. I'm a principal engineer here at TuneIn. And I'm a big, huge fan of Node.js. Been using it for the last 8 years now. Building a lot of services here at TuneIn, using a different array of languages, using Node.js, using Go, using .NET to help build one of the world's greatest streaming platforms. My own personal opinion, also a fact. But Node.js is something that is very close to my heart, and with it is actually something called continuous integration. It really is something that helped me become a better, more comfortable, more confident developer, because I was able to set up a pipeline where bugs would be checked before anybody else would see them. That things that I know should happen were automatically checked for every single time before I do a commit and or before I do a GitHub push. Starting this years ago, it became so ingrained to me as far as how many problems it was actually stopping that it became quickly a habit where it was hard to do it without actually having to set this up. And today what I'm going to talk about is mostly just an overview of continuous integration and a lot of the cloud services out there that can actually help you get up and started fairly quickly. We're going to be talking about Travis CI, we're going to be talking about Worker, we're going to be talking about Wrecker, I'm sorry. We're going to be talking about Circle CI as well. We'll also be talking about code coverage tools. We'll be talking about code coveralls, and also other static analysis tools. And as well as security and vulnerability testing analysis as well from providers like Snike. All of these are cloud-hosted tools that are free for open source projects, but at the same time allow you, if you have a private Git repo or you're using a different sort of repository, the ability to also still use these same services as well. It might not be free. All of these services are free if you do have a public GitHub repo. And just so you know, so this is continuous integration with Node.js. So Martin Fowler from ThoughtWorks has this line, and he says it a lot, and again, it really does ring true. Continuous integration doesn't get rid of bugs, but it does make them dramatically easier to find and remove. And it also makes them quicker to find and remove. It's been one of the biggest reasons that one of the biggest benefits of using continuous integration. So you ask, what is continuous integration? The first part about it is just pushing daily, frequently. Whenever you actually have something of substance or not, go ahead, commit, push, get it in the system, see if it actually works. And also as well, making sure that you have set up systems that automatically test and code, or test your code, run integration tests, run performance tests as that happens. It involves building the code. This is, again, using any sort of hosted provider, or even internally setting up a server such as Jenkins or anything else that will actually, whenever you do this first push, it'll grab it from source control, build it, run the tests, and make sure that it's exactly as you would expect it to run and build and meets all of the required criteria. Again, testing it, making sure it has the required criteria, and then qualifications. Qualifications could be their code coverage, making sure there's no vulnerabilities, making sure that you have code complexity at a certain percentage that makes you happy and easy or more proud of the code that you're actually writing. And then the delivery part is making sure that it's inside of the actual servers are actually deployed so that users, whether it be in dev, stage, or prod, are actually seeing the results of your work with the results of anyone else that might actually be working on this repository. So, and then the last one is to repeat, is to go ahead and repeat that process so that everybody, so that you do this pretty much daily. You push, you build, you test, and then you deploy every single day, sometimes twice on Thursdays. So pushing, these are the few of the repositories that continuous integrations work with. Again, Git, GitLab, Bitbucket, as well as any other providers that support Git and other types of interfaces. Build and test, Circle CI, Travis, and Worker all build and actually run your tests, and also could be set up to actually deploy your application if all of the tests actually pass. This makes it simple and smooth so that you know that whatever enforcements that you have set up are actually enforced before the delivery happens. So we're gonna take a look here at Travis CI. I set up a project here, something quick and simple. It's a microservice called Kickable, and its sole purpose is to answer the question of, can I kick it? And the answer is yes. But only if it's it. I don't want it to say yes if it's something that I can't actually kick. So I've set it up this service, and I've configured a few of the files inside of this project to be able to support Travis CI. But the benefit about it is that Travis CI is automatically hooked up with GitHub. I can see a history of every single time that I've pushed inside of this, and I can also see build and verified pull requests as well before they actually merge into the development branch. This helps me first and foremost, if you are working on an open source Node project, you may get a lot of pull requests that actually take your time to actually review and verify. This cuts out a little bit of that, making sure that anything that you receive from anybody in the internet has at least met your criteria or your standards. When we're doing Travis, again, it will build it and it will compile it. You're able to actually see a lot of the different, the logs of actually what's happening here. One of the benefits of using Travis CI as your build server is that you're able to use up to the latest versions of Node, essentially. And you're able to actually check your package against, or your module against IOJS, Node 7, 6, 5, 4, or however far back, or whatever specific versions that you want to do. The benefits of this is, although I might develop regularly on one specific version, it's good to know exactly how that is supported up and down the stack. Here is an example of Circle CI doing the same thing, listing all of the builds that you have and that you have set up, and just displaying whether they've passed or failed. And again, going ahead and running the actual test to make sure that everything is passing successfully. You can actually see, again, through all of these tools, the actual logs and the tests to make sure that everything is running. And here again, you can see that even with Circle CI, you can use Node 7, and then again, start testing Node 6 and Node 5 against your same process. With Worker is another tool that is actually even more set up outside of continuous integration to do continuous delivery. They allow you to set up pipelines that deploy your code to Amazon, to Google Cloud, and Docker, and a wide variety of different hosts. But a lot of these have very similar tactics, where you have a specific YAML file that you include, specifically if you're working on private repositories. This allows the hosted solution to verify that your repository is exactly what it needs to do. But if you're not, it will actually just access the GitHub repo directly and work as expected if you have the tokens or whatnot in your environment variables. And here you can see that it goes ahead and sets all of those environment variables up and also runs your test. You might ask, as far as environment variables go, what if your service or your application requires special keys or secrets? All three of these allow you to specify environment variables for those builds and to even change them per branch. So if you have a staging master or another branch, they'd be able to actually use the specific environment variables for that environment. And again, qualification. So these are the tools that I use a lot to help make sure that I'm actually making good coverage and having no vulnerabilities as far as the latest dependencies that I use. Coveralls.io does good code coverage and allows you to specify the threshold for pass or failure, and it also allows you to, it has a little bit more detailed code coverage involving branches of the actual code statement. So if you have a one-line if check that has multiple criteria, it'll actually count each of those criteria as far as its code coverage. CodeCov is another one that I use as well. It has very similar support. Each of these provide graphs and stats for over time to allow you to judge the quality of your code as you're building or as you're integrating it. So again, we're going to push and release daily. So we want to see if anything that we're actually contributing to is, and how it's affecting the quality of our code. And Snipe is another one out here that does more vulnerability, or if any modules out there are known to have dependencies that are known security threats, Snipe will essentially flag those and let you know if it's in your project as well. Luckily, I'm not that risky here when I'm actually doing this. And then again, when all that's said and done, one of the benefits is that these give you badges here, actually, that you can put on your site. And this not only helps you know, but it helps the people that are actually going to be using your packages know exactly how well covered you have them, and or exactly how safe it is to actually use it. So yeah, so this is essentially my presentation. The only other thing that I could go to is this other slide, which is improperly placed. Here. Thank you very much. Now, I also am open for any questions if anybody has them.
Hi, I've often heard continuous integration as a term that's sort of touted by really big companies, like, for example, IBM, or they'll sell these continuous integration packages and so forth to their clients. But really, it just seemed like a reason not to deliver an actual finished piece of software that's really been kind of gone through the forge. Whereas continuous integration nowadays, how does that compare with something like software as a service, where in any case, you know, you're automatically downloading this version?
I guess it depends really on the software you're building. If you're relying solely on cloud services and you're trusting their ability to test and build, and you're not actually building an application. Yeah, I guess it just depends on the project you're building. If you're building an application that will rely on a lot of those services, it's still good to have continuous integration, at least in your own code. It provides that comfort, that confidence that whatever I'm pushing is going to work before it hits the repository, because I'm going to get updates from either Git pre-commit hooks or Git pre-push hooks, that the coverage works, that there's no vulnerabilities. And if you were to look at other companies that might provide software as a service, you would really hope that they do the same thing. Yeah. But still, without using any of those SaaS projects, it's pretty easy to go ahead and have software that could easily fail because of just bad practices. Yeah. No problem.
Hi. So one of the interesting counterpoints to continuous integration that, not a counterpoint, but caveat that I had a big enterprise company share was CI is great and super valuable, but when all the bits are burning and we need to get something out immediately, don't mess that up. Don't like force the flow to have to go through that. How have you dealt with that situation? Have you had to go and, like, you know, build the short circuit to the CI?
I'd say it's a lot easier if you build the CI system first. It helps you have those patterns and practices where if it's already set up in place, there's no change. There's no change in expectations. You know exactly every single thing that you have to do and commit to has to meet this criteria. You can make exceptions and say, you know what, I have this priority and I could write tests for it, but it's due tomorrow. And you can go ahead and push it and update your code coverage requirements to adapt to that priority. At the same time, if it's that much of a priority and you're releasing it, you have to ask the question, if I'm only testing this much code, what might break? And ultimately, that's one of the reasons I see a lot of businesses really adapting to that, adapting to code or continuous integration, is because not only does it make the developers more confident, but you're building a more quality product. There's going to be less consumer bugs reported to whomever or to your QA department, and there's going to be just a lot more faith if that is stopped there. But I totally understand your position, because a lot of times those priorities are high and you're just rushing them through. And continuous integration is here to stop that or slow that down so you can actually fix the bugs. If everything is perfect, then there's no problem. But things are hardly ever perfect on their first commits, at least. Any other questions?
I've always thought that continuous delivery was really interesting, but I never had the chance to practically implement it. What do you think about like the prerequisites of how would you go about implementing continuous delivery?
I'd say for Node.js, and specifically for a lot of the services that I mentioned here, I literally committed at 2 a.m. last night this Kickable project, or 2 a.m. this morning. And then later on today, after lunch, I spent an hour just setting up the accounts and updating the YAML files inside of the repository or my environment variables to make sure that I could test it and push everything. So it's practically very simple. In fact, if you were to check out this github.com/devstream/kickable project, you can go ahead and see all of the work that I did and how easy it is to set it up for your own repository.
As far as development environments where engineers are building a lot of different branches at given times, do you recommend all of those branches going through a continuous integration process, or do you consider that just something that when people are actually committed to key trunks in the process?
I think that, again, would be another business decision. I personally would want it everywhere. Because it never really hurts. A lot of these cloud services have different ways of doing it. You can have it as a pre or a post commit hook, but if you have a system set up with your typical Git flow, where you're actually making PRs on separate branches and then having them merge into your main, you can actually make a PR, and then some of these services will actually make comments on your PR saying the code coverage is only 50%. Your security vulnerability is found. And then just when even reviewing these PRs, you can make sure that they're caught before someone else actually merges them in. So that's why I like it. It doesn't necessarily have to hurt you unless you set up a process that allows it to. Any other questions right here?
Feature flags, if you have experience using feature flags with continuous integration, if that poses any challenges, just kind of thinking through it and not.
Sure.
I think that either cause problems or not, and I'm kind of curious what your
No, they can cause problems. Not all of these services have the same ability to use the same Node versions. On some, you might need to wait for them to support Node 7 or whatever the latest version is. And on others, you might need to literally download and install inside of their Docker container whatever specific version of Node you want to test against, build it, and then actually run your test. So as long as they provide that same sort of flexibility, I believe you're covered. I know that Circle CI uses NVM, so that does give you some flexibility there as far as which version you are using. And as far as the feature flags, you can still use or pass them to your test when you're running them. But again, I guess it's more of a project requirement as far as what languages you are allowed to support. If I were to go back here, one thing I did forget to touch on was here. I have at the bottom here requires Node.js 6 plus, and IOJS is not currently supported. Again, one of the reasons I knew this is because I actually went to the builds and used Travis CI and added all the Node versions and said run it. And it let me know right off the bat that 5 and 4 and IOJS do not work. And it's because of it's because I'm using Ava as a test library, which is more expressful, and more modern. So it requires a lot of other services like Babel or transformations for that. So I was quickly found that and updated the documentation to be able to reflect exactly what versions of Node are supported. And if you are using specific feature flags, you can identify those and make sure that they're included in the documentation for whomever's using it as well. Any other questions? All right, guys, it was a pleasure talking to you all. It would be amiss if I didn't say that we are hiring at TuneIn. In fact, we have 4 web developer engineering positions open and 1 senior or 1 manager engineering position open, not to mention a senior developer on the streaming team, the team I'm on, again, building the world's best streaming platform. Thank you, everybody.